Hello, Honor Statistics. This is Mr. Kim. Like I promised you guys, this is the review video for all the questions that I'm giving you for the review packet. Some of you guys got this today, yesterday, or even days before. What I'm going to do is I'm going to go through every single one of these problems and make sure that you guys know the steps as to what's to be expected, like how to do them and things like that. Just to give you a little bit of a update, you guys know that next Monday is going to be your test. There's going to be 10 multiple choice questions. There's going to be 2 free response questions, and that's it. Out of the 2 free response questions, as you already know, you're asked to finish one of them completely. Free response questions has multiple parts. Based on how much of that you get right, you will get partial credit for it. If you do have the time, I suggest you try on doing the other free response question as well, because I'm picking the best one out of the 2. Of course, with the time restrictions and everything, you might not be able to finish everything. So you want to manage your time well in the midst of all this. If you manage to get both of them and both of them correct, then I'll give you extra credit. And we've already talked about that during the class, but that is how the format of the test is going to be. Okay. All right, so without further ado, let's go straight to question number 1. And so the answer here, as you can see, is B, but I'll explain this to you guys why it's going to be here. So the very first thing is, which of the following could be the median age? That's what the question says. A lot of you guys are in the class when some of you guys asked me how to do this, what are we supposed to be doing? They ask you for the median. And when I ask you what a median is, a lot of you guys can tell me, oh yeah, median is just the center, like the center of all the data points. That's great that you know that. But if you don't know how to apply it on a question like this, then it's no good. So you have to be able to apply it in a histogram like this and think about crossing out boxes. Okay, so that's what you're gonna do. So Mr. King, what do you mean by crossing out the boxes here? Well, you know that you're crossing out the low end and the high end of the numbers. So between 5 and 10, I know the 10 is not labeled here, but that's where 10 is. There's 7 numbers between 5 and 10. Now that could be 5, that could be 6, 7, 8. For all I care, I don't really care about what the numbers themselves exactly. All I care about is that there are 7 numbers here that I need to cross out from the list. If I cross out 7 numbers from the low end, that means I'm crossing out 7 numbers, 1, 2, 3, 4, 5, 6, 7 numbers from the higher end. Now I have 8 numbers for the second bar. Let's say I cross out all of these 8 numbers, 4, 5, 6. Well, that's not, you get the idea. That's 8 numbers. That's 1, 2, 3, 4, 5, 6, 7, 8. You can also count like where they are. That's 3, 4, and that's 1 left over from the previous. So all of this adds up to 8. Then there are 9 numbers in this gigantic peak. There's 6 numbers here. So let's say I cross out these 6 numbers. That gives me 6 numbers to be crossed out here. Then there are 3 numbers left. So I cross out 3 numbers here. Now, what you see is that this bar right here that I'm coloring for you in black, that's where the median is going to be, because I literally cross out all the numbers from either end of the spectrum, and you find out where the middle number is. Now, that bar, all the numbers that's contained within that bar is between 20 and 25. The only answer choice that is actually within that boundary between 20 to 25 is B. So therefore, this is the only answer for the first question. Okay, so remember how to find the median for the next time when I give you a histogram. Just make sure you cross out the bars. Number 2, I was surprised to see that some of you guys didn't quite understand how to do these questions, but whenever you see this, I'm going to erase all this just to kind of start over. The first and foremost thing that you always want to remember is that range is from minimum to maximum. Like that's literally what range is. Quarter 1 to quarter 3, that is IQR, interquartile range. It's the difference between Q3 and Q1. There is no way that IQR, that distance, is going to be bigger than your minimum to maximum. That just physically cannot happen. Look at the length of that versus Q1 to Q3. That is just not going to happen. So when I see that the range is less than IQR, I'm just going to erase that right there. That makes no sense. So now we're really down to these 3 choices where mean is greater than the mean is less than the median is equal to the median. The only way to solve this is if you guys have studied the shape of the distribution. Now, I am never going to ask you to find the mean of something like this. There's no way to find out the average because you don't know what exact numbers are. Like you don't know what numbers are between 5 to 10. There are 7 numbers. Like they tell me that there are 7 numbers right here, but I do not know exactly what those numbers are. So how do I figure out what the mean is? Well, in blue, I've already labeled it for you. This is skewed to the right. You guys have to be able to tell me that at this point. I'm not going to go over the shapes of these things. You guys should all know that. If it's skewed to the right, remember that the mean is always pulled towards the direction of the skew. So if it's pulled to the right, that means mean is also pulled to the right where all the higher numbers are. So the mean in this case, when it's skewed to the right, is always greater than where the median is. So here, if I'm looking for the answer, I am picking C because mean is greater than the median because it's right skewed. Well, then how does that explain what answer choice D and E would be? Well, if mean is less than the median, it should be skewed to the left. Why? Because mean is pulled towards the left means that the mean will be in the smaller value spectrum. So the median will be greater than the mean in this case. Median is somewhere in the center, whereas mean is pulled towards somewhere to the left. So it's going to be in a lesser value. E is where it's roughly symmetrical. So it's going to be where mean is about the same as median. We talked about this in the notes. Please refer back to that if you're confused about this. Next question. 40 students took statistics and has worth 50 points. Okay. The dot plot displays the data. The third quartile is. You are not going to simply just estimate all of these values and try to put them in the calculator, do a one variable statistics and figure that out that way. That just takes way too much time. They tell me exactly how many number of data points there are. There are 40 students, which means if I cross out 20 and 20 numbers on either end, I find out the median, right? So let me erase all this and just start from the top. There are 40 numbers from the get-go. I split that into 2 because if I try to find out the median number, it's got to be in the center of those 40 numbers, 20, 20 on either end. Quarter 1 and quarter 3 is exactly halfway of those halves. This is where quarter 1 is, and this is where quarter 3 is. So let's say I'm trying to find out quarter 3. That's where my attention should be. I have 20 numbers in the first half, 20 numbers in the second half. On the second half, if I cut that into half again, wouldn't it make sense that that's 10 numbers on either end like that? So what that means is I am counting 10 numbers from the end going in that way. So I go to my list, and these are all my dot plots of the data. You can see already from the work that I did, I crossed out those dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I crossed out 10 dots so that I know where my median is going to be. Here, no matter where you go, 11, 12, even beyond that, that's all around 44. So my answer is B. Okay. Next question. The standard deviation distribution house age is about 16. The only way to understand this is if you were to go through every single one of them. I'll explain this to you guys why E is the only one that makes sense. The age of all houses in the sample is within 16 years of the mean. All the houses? No, that's not what a standard deviation is. That literally means if the mean is here, everywhere, all the age of all the houses is between like plus and minus 16 from the center. That's not what standard deviation is about. It's just a deviation away from the mean. I know that it has, within 16 years from the mean, but the problem is that all houses cannot be accounted for within one standard deviation away. We'll go over that in chapter 2, why that's the case. But you can't contain all houses within 16 years from the mean. The gap between the youngest and the oldest, 16 years is a standard deviation, not the range. Youngest and the oldest is max and min. This is talking about the range. So therefore, B is out. C, the age of all the houses in the sample is within 16 years from the mean. The same problem with A. The word is all. You can't contain all of the houses, houses. You can't contain them within one standard deviations. The gap between first of all, this is IQR. E, let's read this carefully. The age of the houses in the sample typically varies. There's no all the houses. There's no all. Just the age of the houses in the sample typically varies by about 16 years from the mean age. Perfect. That's the definition of what standard deviation is. Typically varies. Not all the houses, not all the age is contained within that category. like within 1 standard deviation. That is not the truth. That's not the case. So the correct answer here is E. The next question here, what percent of all small companies? So when I was solving this, because they told me out of all small companies, what I first decided to do was add up all the small companies here. Oh, for some reason, oh, there we go. Okay, so there was a little bit of a lag within the iPad, but I think it's all just good now. Okay, so for the 5th question, what percent of all small companies receiving questionnaires responded? So we are talking about just all the small company people. That means I'm really just adding those two numbers up. 125 and 75 put together, that gives me 200. So out of those 200, how many responded? 125. 125, 200, type that in your calculator and you get 0.625. Make sure you know how to translate that into percentages, please. You move that right twice, and that's 62.5. Next question. Which of the following conclusions seems to be supported by the data? Now, these are the types of questions I asked you guys to do. On most cases, I like to hear the stories behind these numbers. So to understand this, again, you need to be able to go through every single one of them. So I'm going to go through every single one of them here. There are more small companies than large companies in the survey. Well, I've already found out the total number. So let's compare. I have 200 small companies versus 200 large companies. There are more. No, they have equal amount of companies. Makes no sense. Small companies appear to have higher response rate. Guys, rate is a proportion. Proportion means a fraction. Like out of how many, like in total, out of total, how many were this kind of thing. So have a higher response rate means the responses out of the total. So small companies, the response rate was 125 out of 200. That was the answer we got from T1.8. Medium or big companies, that's 81 out of 200. And that's 40 out of 200. Okay. No matter how you do this, 81 out of 200, 40 out of 200, you can find the percentages too, but that's not going to beat the 62.5%. So small companies appear to have a higher response rate than those two companies. Yes, that's absolutely true. Let's go over these two just to make sure. Exactly the same number of companies responded as didn't respond. You can see for yourself why that's not true. 246 versus 354. Overall, more than half of the companies responded in the survey. No, that's 246, not 300 out of the 600. If it was about half, it should be around 300 people who responded, but I only have 246. If we combine the medium and large companies, then the response rate will be equal to the small companies. Not true. Again, compare 125 out of 200. That was the response rate of the small companies. The medium and the large companies put together, that's out of 400 because you got to put those two companies together. Out of those, it's 81 plus 40 who responded. I guarantee you 121 out of 400, that's nowhere near 125 out of 200. Check the math. That makes no sense. It's B. All right, next question. Which of the following is not a correct statement? Not a correct statement. We've done this a lot on our scavenger hunt questions. So I see a lot of these, box plots, and one of them has an outlier. So probably this is one of the hardest questions that I probably gave you. This is the last, I believe, in open the multiple choice question. It's not a correct statement. So let's go through every single one of these and see if any of these make sense or not. At both high and low concentrations, the new chemical results in better weed control than the standard weed killer. So high and low concentrations, which means I don't really care about which graph I'm looking at. The new, so I'm looking at the ends, results in better weed control than the standard weed killer. So I'm comparing that to S. If I have higher percent of weeds that grew, that's not a good thing for me, right? So for me, it seems like the new chemicals here, they have these lot of numbers, data set on the lower end, which proves to me that, oh, this new chemical that we're applying, it kills a lot of the weed that's growing. So the percentage of that is actually going down. So this is actually true. But remember, we're looking for the sentence that is not actually true. For both chemicals, a small percentage of weeds typically grew at a higher concentration than at lower concentrations. Okay, so we're comparing now the low concentrations versus high concentrations, but that's not true because if you take a look, on the low concentrations, we have both one that actually is really spread that goes all the way to the minimum section, but then we also have on the standard weed that actually standard I guess the weed killer that actually has on the higher percentage of weeds that grew. So it's not a matter of low concentration versus high concentration. A small percentage of weeds typically grew at a higher concentration than at a lower concentrations here. So let's take a look at the lower concentrations. Actually, if we think about it, small percentage of weeds typically at a higher concentrations. Right. So for this one, this actually also does make sense because it's really hard to kind of think about what this is saying. But high concentrations for the standard versus low concentrations for standard. Look at how less percentage of weed that grew versus this one. So, and for the other one, yes, this one has, it's the high concentration for the new chemical. And we also have a couple of outliers. A smaller percentage of weeds typically go at a higher concentration than a low concentration. So it's really hard to say for the other one here. So I'm going to leave myself a little bit of a star for B because it doesn't really apply for the new chemical. C, the results for standard weed killer are less variable than those at the new chemical. Okay, variable means spread. Okay, this means spread. So which one has more spread? Which one does not have more spread? So the standard weed killer is from here to here. That's your typical spread. And from here to here, that's your typical spread. That's very small spread. So weed killer are less variable for standard. Yes, that is absolutely true. For B, I'm going to erase that just because I'm a little iffy about what it's talking about. High and low concentration of either chemical have approximately the same effect on weed growth. Okay, first of all, that is completely not true. I mean, we're picking the one that doesn't sound like to be true. And let's take a look at either chemicals in low versus high concentration. So for example, this is the low concentrations for the new. This is the high concentrations for the new. We have these bunch of various different data sets here. We got a couple of outliers here that gives me a higher, percentage of weeds that grew versus this where it's standard, that's a low concentration versus high concentration. Now, I wouldn't consider these two to be similar by any means. It says of either chemical have approximately the same effects on weed growth. They do not, because look at the blue and the yellow. They do not have a similar output of weed, percentage of weed that grew. So this one is clearly the one that I feel like is going to be the answer. Some of the results for the low concentration weed killer show a smaller percentage of weeds growing than some of the results for the higher concentrations. Yes, that's true, because for the low concentrations, they show a smaller percentage, right? Look at all these smaller percentage down here for the green compared to the high concentration, which is only the minimum is down here. So compare the green to purple for the same type of the weed killer. Yes, this definitely shows a smaller percentage of weeds growing. Yes, that's absolutely true for the lower concentration. So for B, both chemicals, a small percentage of weeds typically grew at a higher concentrations than at lower concentrations. Technically speaking, for lower concentrations, we do have a lot more variability. We have a lot more small percentage of weeds typically go at a higher. Oh, actually, yeah, that makes absolutely sense, because at a high concentration, we have a lot of, weeds that are growing at a lower rate versus in a low concentration, we have a lot of, percentage of weeds that grew on a higher rate. Okay, so that is absolutely true. So the correct answer here is going to be D. This was actually really, really tough. And for these types of questions, you actually have to go through every single choices. So again, there's always the best amongst these all. There might be two typical ones that might stand out, but this is clearly the one that's going to be the answer here. This is absolutely not true. All right, so now we're down to 3 response questions. And some of these, I think one question we've already did with comparing the batteries. So I'm going to go through these a little bit more swiftly compared to the previous question. So the household incomes. Some of you guys already asked me about this. For part A, about what percent of each group of households consists of 4 or more people? What I did was I went to the 4 or more, household size, 4, 5, 6, and 7. And then I kind of eyeballed where their percentages would be. So like, for example, like this one, like where the 4 is, like 4 households, That's about like 5%-ish, because that's from like 0 to 10%, halfway there. Then that's about half of that, half of that, half of that. So I estimate it to be around, for the low income, to be about 8%. And for the high income, if you add up all of these numbers, just eyeball the percentages, I said about 38%. Now, am I going to take points off if it's not exactly 8 or 38%? No. If it's similar, I'm going to give it to you. Let's say like you told me that was like 83%. That's completely not true. So just watch out for those crazy numbers and you should be good. Part B, describe the similarities and differences. I am only giving you one thing that I want you to tell me. The similarity between these two is simply the range of the household size. That's what I said right here. The variability. Always talk about SOCs here, okay? Because we're talking about distributions and we're trying to find the similarities and differences of distributions. Whenever you see distributions, I told you those 4 letters are your magic letters, best friends forever. So the variability spread is the same because it's from 1 to 7 household. I've specifically mentioned those numbers. If you do not follow this template to like, not to the nitty gritty detail of it, but if you don't give me like these sentences to work with, I can't give you full credit, because if you just tell me that, yeah, the similarities is spread, how do you know? Can you tell me some numbers to prove that? Yes, I can. It's from 1 to 7 for how high income families and 1 to 7 for the low income families. Whereas the shape is different. Yes, definitely. The shape, I understand that they're both kind of skewed to the right, but one is clearly more skewed to the right, whereas this one is a little bit more, like, a little bit less skewed to the right. We can call this like, roughly, skewed to the right. And this is just straight up skewed to the right. So the shape is obviously different. So I mentioned that low income is more skewed to the right in a sense that's more. Then for the high income, it's also kind of approximately roughly symmetrical. You can kind of argue with that because of how the data is shaped right here. But if I had to pick a choice, like A, B, C, skewed to the right, skewed to the left, and roughly symmetrical, this is I will pick skewed to the right for this one. But in a sense, compared to this, not even close. The first one is skewed to the right more than the second one. Okay. All right, for this one was actually quite easy to do. All you have to do was just find out the total column for me. If you haven't done that already, please do that. What percent of students who responded were Facebook users? Now, the question is, what percent of the students, if you read the context here, is there a relationship between Facebook use and age and the age among college students? So all of these total number of people that I put down here, 219, which is same number here, that should be the number of people who answer the survey, and those are the number of the students. So out of those students, who are Facebook users? Well, the Facebook users here, I think I found it in this row right here, saying that it's, yes, I have 148 Facebook users. That's 148 out of 219. Do you do the math using your calculator? Tell me the percentages. Yes, I do want it in percentages, and if you can tell me in the fractions as well. I want them both. For part B, what percent of students who are aged 28 or older? 28 or older is this one. Is this column right here. 67 out of 219. Nothing too much to go over there. Again, give me the percentages. Part C, what percent of students? Once again, my denominator number still doesn't change. Out of those total number of students, how many were how many aged were older Facebook users? Older Facebook users is this number only, because that's the category of older and the Facebook user with the yes. That's 21 only out of 219, roughly about 10%, 9.6%. Last one gets a little bit more interesting. What percent of the Facebook users only? So out of only the Facebook users, your total number now has to be 148. Your denominator number has to be 148. Out of those, only those who are younger students, 78. Yes, I understand the younger is 82 in total, but these 4 we exclude because they're not part of the Facebook users. So that's 78 of 148, 52.7%. All right, next question. So we have guinea pig survival times, and I give you a lot of data points here. The first question is make a histogram of the data. I have put this in the data set. Oh boy. Okay, so I lost all my data from the calculator. But what you would do is, let's say that you would use your graphing calculator. Okay. And can't believe I lost all the data sets. So you're going to type in all the data points for me. So you can do 43, 45, 53. And if you ask me, is there a faster way to do this? No, just take your time, type the data in, and you should be able to get it correct. Now, what you will get is when you type in all of these data points, there are two things you need to keep in mind. Number one, you press second, which is the blue button at the top left, and y is equal to. You guys must all be able to turn the stat plot on, go to the second one. The third one, zoom right here and press number 9. Now, this is obviously not the histogram that you should see, but you see this histogram based upon zoom 9. When you do this correctly, this is what I had for the answer. So we have a lot of numbers between 40 to 140. I gave myself a 100 interval. How do I change the window setting? Well, you can go to the windows right here. Okay, that's right next to y is equal to. I can change x min to be 40, change x max to be whatever it is, like 640 or something like that. Oh, sorry, this has to be 640. And your x scale can be like 100. So you're moving up by hundreds each time. So this is what it's going to look like. Everything is moving up by 100. And so once I put in all the data and I got it, this is the histogram I saw. And when you do stat calculations for one variable statistics, press calculate. Remember all of these wonderful things that's before you with the mean, standard deviation, the 5-number summary, right? Quarter 1, quarter 3, you can see in the calculator right here, median, maximum, 53, 53, 45. You guys should all know how to do that, okay? Calculator stuff during the test, if you ask me questions about it, I'll do my best to help you out. But it's much better if you guys are fluent with this from this point onwards by yourselves. All right, so make a histogram. Does it show the expected right skew? Yes, it does. I can clearly see a lot of data is congested around the 40 and 140, which is pretty much all the data here. All of that is between 40 to 140. So that gives you a very high number of frequency. Then it slowly starts to die down and we have a right skew. Now make a box plot. I had the 5-number summary. Just please check with your own math that these 5-number summary matches yours. I took those 5 numbers and I just plotted the box plots myself. Now you feel free to use your graphing calculator capabilities to plot this yourself. There's one that has these little outliers and one that doesn't. The one that I have with the outliers, that's much better because first one is better. Either one is okay. That's what I said for part B. Why is the first one better? Because it reveals outliers. And it also helps you answer for question part C. Compare the histogram to the box plot. What's the one feature that you can't see? All of these wonderful outliers that's beyond this right here, which we can't, well, that's quarter 3 of 151. It shows you where the outliers are. Whereas histogram, you never know if these are outliers or not. You might have to use your IQR rule or whatever, but it's much better just visually from visual perspective. Box plot with outliers, you could just tell me where it is right away. So that would be the main difference. All right, so the next question is part A. This is not something that I wanted you to answer, but I just still gave it to you just in case. But if you don't get part A, it's completely fine. I'm not going to give you a question like that on the test. This is a statistics because we are taking only a sample of the athletes, not everybody. A population gives you a parameter. Sample gives you statistics. That's what I told you guys right here. For part B, write a few sentences comparing the distributions. Look at all the things I've written down. Yes, I am expecting you to be able to do the same because we've done that before. You texted it to me before with our little exit ticket question. You're mentioning socks to me. Do you see the shape? If so, don't tell me that the shape is just blank and blank. Tell me the description. Tell me the context of it. Okay. So what I said was, if you're comparing these two, the word here is comparing them. So you got to give me some comparison words. Mr. Kim, what do you mean by comparison words? It means like compared to the other student, varsity student has a lower center compared to the other student of 292, 261. I want to see numbers. I want to see the comparison words like lower. There are 2 outliers for other students at 478 and around 430 because this one is really not specified because it's not max or anything like that. And for the varsity students, and they only have 1 outlier at 398 for varsity students. They both have similar shape. Again, comparison words. They're both skewed to the right. Other students have higher spread. Comparison words. From 197, numbers. Give me the data to support your argument. To 478, always give me the intervals of numbers, like intervals from this to that, minimum to maximum. Whereas varsity spreads from 189 to 198. I mentioned all of these components: outlier, shape, center, spread. Gotta mention to me everything. All right, this is the last page of the review. And so for the last page, what I have is construct a histogram. Again, I use my graphing calculator. I wish I could show you from the Google Chrome that I just pulled up, but just deleted all my data. So I'm so sorry, but that is what I have. So if you were to do the same, type in all the data points into your calculator, zoom 9, stat plot, all that good stuff, you should be able to see this. Now, are there any outliers? Justify your answer. When they ask you to justify your outliers, that's your cue to say, okay, so they want me to do this thing. That's what they want you to do. So how did I get this IQR? I can't straight up tell from the histogram. So you have to use your one variable statistics. Remember, if I go back to my calculator here, it's this thing. How do I get to that? Stat, calc, one variable stats, go to calculate, gives you these wonderful things. So I took my quarter 1 and quarter 3. I understand it's not the same thing as the calculator says for my answer key, because the only numbers I have in my list is these 3 numbers, just to show you guys what's up. All right, so here, let's say I type in all the data and you do one variable statistics. You should get these 2 numbers. Quarter 1 and quarter 3 is 30 and 77. IQR is 43 because you subtract these 2 numbers. 77 minus 30 is 43. 1.5 times IQR. That magic number, I am not even going to tell you. You better memorize that. 1.5 times 43 is 64.5. With that number being said, what you need to remember is, okay, so that means anything beyond 64.5 from quarter 3, anything below 64.5 from 30, which gives you a negative number, makes no sense. So the only thing I really have to consider is adding 64.5 above quarter 3. That's 141.5. That's your boundary cutoff line. What's your outlier? 151. Why? Because 151 is bigger than your cutoff line at 141.5. Anything less than 141.5, we're still not going to consider as an outlier. But since it's more than that, that's 1, by the way, that's not 400. 141.5, if it's more than that, then only then is an outlier. So how do I justify it? 151 is an outlier because of the IQR rule. That's really all you need to tell me, and show me the work for the IQR rule. Would it be better to use mean or the standard deviation, or median IQR to describe the center and the variability? The magic word here is the word that starts with R called the resistant. We want to use median and IQR to describe the center and the spread for this one, particularly because they are more resistant to the outlier that we just calculated for part B. We found out that 151, I think it was, what was it? What's the unit? Contact numbers. So the number of contacts we have for 151 is an outlier. If I have an outlier, I don't want to use the mean and the standard deviation because they're not really a good way of measuring the center and the spread. They're not resistant. Therefore, we want to use IQR and the median to describe the center and the spread. All right, last question. This is something that we've already done. So again, it was kind of like a Shark Tank question. Part A, what is the longest lasting battery? That's 550. Please just read the key for that. 5.5 is not 55 hours. Like 4.2 is not 42. They say it was between 420 to 429. Just to be more specific, I can say 550 to 559 hour, just to be more specific. But 550, if you guys said that, that's totally okay. Give a reason someone might prefer brand X. So this is the reason for brand X right here. One reason why someone might prefer brand X is because it has a yield of the greatest number of hours left in the data set. I told you why, and I told you also numbers. I like to see the data to support your argument. Brand X has yielded the highest maximum amongst all the batteries. Also, it has the higher minimum compared to brand Y's minimum. So you're trying to do a little bit of a comparison to brand Y and saying, hey, we're better than they are because look at my minimum versus their minimum. It's a guarantee out of the samples that, hey, even if we're trying to pick the lowest one, we're not going to go as low down as brand Y because brand Y only offers 170 and our battery is guaranteed to offer you at least 300 hours. Good reasons to pick brand X. What is a good reason to brand Y then? Well, some of you guys might say, oh, it's more consistent. It's more somewhere along those lines. But please remember that I want one reason. And one solid reason can come from this. Anything that deals with socks that describe the distribution, you're all set. The one component that brand Y has over, like an overage over brand X, is the center. If you literally calculate the median for brand Y, it's going to be at 430. You cross out numbers from either end, you find that it's 430 hours to 439, just to be more specific. Compared to brand X, you cross out the middle numbers, it's going to be somewhere around here, 390 to 399 hours. So the center is certainly higher, which means you could probably argue the point where, generally speaking, by average, by picking out the middle one, that is one way of measuring the distribution of all of these data samples that we have. Because the center is higher, you want to go for brand Y. Perfectly legitimate way of arguing for your case for brand Y there. Okay. Remember how I phrase these. Please remember for the free response, if you're not giving me enough to work with, I'm not giving you full credit. I'm only giving you partial credit, or if not, no credit at all. I don't want to just see certain things. I want to see everything. So make sure you take your time and practice the FRQs during over the weekend if that's your weakness. Multiple choice, please remember just, key components. Something like this, I'm not really going to give because it just takes too much time to read and just like think about. I just want you to spend more time on free response than the multiple choice, if anything. Hope this helped. I just study over the weekend. Let me know if you guys have any questions. Feel free to shoot me an email. And have a good night. Take care, guys. Bye-bye.